Okay, Earth Science time. Today we are talking about cycles, specifically rock. So we're going to talk both about rocks and the rock cycle and cycles in general. We're going to leave the cycles in general part kind of vague because I think for one thing you've heard a lot of it in biology and in your elementary school. But what in general, what is a cycle? What does a cycle remind us of? What does the word cycle mean? Pretty good. Cycle.
Put some arrows in it.
A cycle is like unto a bicycle, or a unicycle, or a tricycle. No, people don't usually say quadricycle, but someone does call four-wheelers quad bikes once in a while. But the point is that the word cycle means like a wheel or a circle. The water cycle, let's diagram that real quick. Let's put some arrows in there, as Kyler says. Let's put some arrows in here. What do we call, here, I'm going to put that, I'm going to put that, I'm going to put that. There we go. This is now, I've just drawn some very basic symbology, but now we can fill out this as the water cycle. What's this one? What's this step in the water cycle? Yeah, what's it called though? Precipitation.
Yeah.
Precipitation. Think. Precipitation. What about this one? Yeah. We'll talk more about this in the future, but do you happen to know this one?
Groundwater.
Yeah, when the surface water becomes groundwater, it's called infiltration. What about this one? Evaporation. What about this one?
Clouds.
Condensation. Goes around and around. Does every step have to be used every time by every water molecule? No. Is it possible for surface water without infiltrating the ground to evaporate and become a cloud through condensation? Yeah, of course it is. It doesn't have to go in a circle. We don't have necessarily a starting point, because it's a circle. It doesn't have a start and a finish. It's a circle. That's the point of what a cycle is. Your book goes into a fairly large degree of detail of the carbon cycle, of the phosphorus cycle, of the nitrogen cycle, of the water cycle. But the one we're going to focus on today is the rock cycle. Partially, as I said, because I think you already have a fair understanding of the other ones, I hope, from biology, but mostly because I like the rock cycle. I want to spend most of my time talking about the rock cycle. So this is a cycle in general. This is called the water cycle. I think I could label it. Water cycle. I'm going to immediately erase that. And I'm going to draw another circle. So let's make this one in a more magnetic color. Pretty good again. What are some nouns? What are some vocab words, some things that I can put on my rock cycle that are nouns?
Rock.
Rock, okay. Guess I'll put that in the middle. Rock.
Sand.
I don't know why it makes it so difficult for me. Let's put sediment somewhere over here. What else?
Metamorphic.
Thank you. Let's put somewhere. Let's put metamorphic rock. Metamorphic rock. Igneous rock. And sedimentary rock. Someone says from the peanut gallery. So there are all kinds of rocks. What is the definition of a rock? Remember, for minerals, we had like this pretty strict criteria that it had to be solid at room temperature, it had to be inorganic, it had to be abiogenic, excuse me, had to have a crystal structure, had to have a definite chemical composition. How would we define a rock? I'll give you a hint. It's quite a bit looser than that.
You look at the ground.
No, that's not really it. A rock. Give me a basic definition of rock. It's not going to have as many criteria as minerals did. What's a rock?
A rock. Mixture.
It can be minerals. It can be a mixture. So we can start with that. So it can be a mixture of minerals. Can be a mixture. It can be minerals. a lot of times we think of, especially in physical science, we think of mixtures as like maybe necessarily liquids or like a liquid solution. But it is a mixture. Rock is oftentimes a mixture. It doesn't have to be a mixture. It can be a mixture. It can be minerals. Let's say what it actually is. What must it be?
Solid.
Solid. Okay, what else must it be?
Hard.
It doesn't have to be hard, or at least that's kind of a term that we wouldn't use normally. They often are hard. A solid earth material. I'm just going to put that. A solid earth material is a rock. Solid earth material. It can be a mixture. It can be made of minerals, but it doesn't have to be. We talked when we did the minerals about my necklace here. This is a rock. You see it? You see it here?
Yes.
This is a rock in here, but it is not a mineral. Why? What criteria that was a mineral does this not meet? We talked about this last time.
Naturally occurring.
It is naturally occurring. This did occur in nature. Good guess, though. What are some other things that make that this is a rock that's a solid earth material, but it's not a mineral because it doesn't have a definite crystal structure. It's shaped like a crystal. Someone cut it like a crystal, but it doesn't have a crystalline structure. Rocks don't have to have a crystalline structure. Can rocks have a crystalline
Yes.
structure? Yeah. Can rocks be made of minerals? Yes. But they don't have to be. So rocks are any solid earth material, and they can be made of minerals, but they don't have to be. What were the two ways we talked about that minerals form? Do you remember?
Solution
From solution?
or from magma?
From magma, from cooling magma. And rocks can form in those two ways also, but they can also form in other ways. Let's now that we have our nouns up there, let's put some verbs up here. Let's put some processes. By what process can something become an igneous? Let's put some more nouns up here actually first of all though. Could the noun magma go up here somewhere?
Yes.
Let's put magma up here somewhere. What's magma?
Liquid rock.
Liquid rock. It's rock that has melted. If I draw an arrow, let's play it this way. You label the arrow. By what process could sedimentary rock become magma? What would we call that? Could this ever happen? Can sedimentary rock become magma? How? What would we name that process? Melting. Can magma become igneous rock? Heck yeah, it can. That's what the definition of igneous rock. What do we call that process? Cooling. We have another word too. Cooling and what else must it do?
Pressure.
No, it doesn't have to do this. I guess cooling. Let's just leave it at cooling actually, because I was going to put cooling and crystallization, but I just got done telling you that it doesn't have to crystallize. Oftentimes we'll put cooling and crystallization. Most igneous rocks are made of crystals. Most igneous rocks are made of minerals. The one I'm wearing happens not to be, but cooling makes it igneous rock. Can igneous rock become metamorphic rock? Let me relabel cooling over here. How could igneous rock become metamorphic rock? So this is already a solid. How could this become metamorphic rock? What process forms metamorphic rocks?
Pressure.
Freezing.
Heat
Heat.
and
Pressure.
pressure. Not what?
Cooling.
No. Not what? What must not happen in order for it to become a metamorphic rock? God bless you.
Melting all
Melting.
the way.
Not melting. Can an igneous rock become sediment? By what process could an igneous rock become sediment? And another thing too.
What?
Weathering and erosion. What's the difference between those two? I'm just going to say it now. This is very important for science. What's the difference between weathering and erosion?
Weathering is
Weathering
it
is
actually breaking
Yeah.
apart?
Yeah, exactly. Weathering is it breaking apart, and erosion is it moving. Yep. But both of those things often happen together, and then we group them together into sediment. Or that's how any of these rocks become sediment. How can sediment become sedimentary rock? How can your chunked up pieces of a crayon or your chunked up pieces of a starburst become? Yeah, we call this process lithification. We sometimes call it compaction. It sometimes includes cementation. Lithification means to become what? Can you guess? Lithos in the Greek is? Isn't someone taking med terms?
Liquid
you did last year, what's lithos?
I don't know.
Stone. So this just means like to become rock. Lithification means that it goes from something else to become rock generally. But we use it in geoscience specifically to mean when sediment is lithified, when it becomes a rock instead of loose sediment. What's compaction? Right, not to the point of metamorphosis, but still pressure. And cementation, when they become what?
Sediments.
No, the root word there is cement, when they get cemented together. When they're basically, we're not leaving yet, are we?
No.
Alexa is. Or not Alexa, Haley is.
12 minutes.
About like 12 minutes, okay, good. Now, can sedimentary rock become sediment by weathering and erosion, and then under lithification become a new sedimentary rock? Yeah, this is one of the key pieces of the rock cycle that people sometimes forget. It's like I said about the water cycle. It's not having to go, it has to go from sedimentary rock to magma, cooling to igneous rock, that becomes metamorphic. Igneous rock can melt to magma and then cool to igneous rock again. They can self-cycle like this. Metamorphic rock, of course, can be weathered and weathering and erosion. Any noun on here, pretty much, can do any of the processes, any of the verbs to become another one. It's not that it has to go from sedimentary to igneous to metamorphic, to sedimentary to igneous to metamorphic. That's a misconception some people have. So now we're going to talk about each of these types of rock. You have questions about the rock cycle in general before we move on? You know what a rock is?
No. A solid earth material.
Solid earth material. Do you know how rocks can form? Let's do some examples of the ways rocks can form. Now we're going to talk about the types of rocks. If I had another whiteboard, I would show it to you, but I don't, so I'm going to erase this. Does anyone have a reason why I shouldn't erase this? Speak now or forever hold your peace. Okay.
Speaking now.
Speaking now, it's too late, dog. That's okay. Did you get it, though?
Yeah.
How much?
All of it.
You just playing a trick on me?
Yeah.
Oh, okay.
Metrics.
Which one do you want to start with? Which specific kind of rock do you want to start with for its types?
Sedimentary.
Sedimentary. We will go into more detail in all of these. Number one, when we go over your lesson self-checks, because you don't really have time right now, but we'll get the basics out so that Allie has something to show for it. But we'll go into more detail when we do the lesson self-checks. And for igneous, we'll go into more detail in the processes about igneous activity. And for sedimentary, we'll go into more detail for the processes about sedimentology, erosion, and weathering. So, sedimentary rock is usually graded by grain size. It's categorized by grain size and I guess I'd say shape. Sure. Grain size and shape. Grain size and grain shape. In order going down, grain sizes are the biggest grain. Sometimes when we're talking about sedimentology, we're talking about erosion. A lot of times we'll say things like the type of erosional material is boulder size, so we sometimes include boulders and things like that. But when they're making up rocks, we usually say pebbles is the largest size we commonly talk about. Pebbles. Would you, since you're on your computer anyway, Connor, would you look up for me the sizes of these? So like you'll find a grain size chart and it'll say pebbles and it'll give a range of sizes. And in fact, it might be in the book, but I don't think it is. Why am I going to have you look it up?
4 to 64 millimeters.
4 to 64 millimeters. Okay, the next one down, you might remember this from 8th grade science, so I'm going to ask you these questions. What would be the next size down from pebbles?
Down.
Yeah, what's smaller than a pebble? That sounds like a Monty Python question. Like, what's smaller than a pebble? There's lots of things smaller than a pebble. But I mean, of grain size, what's smaller than a pebble? Sand. And then we sometimes grade them into coarse, medium, and fine sand. What's coarse sand size? Kyler? I bet it's going to be something to 4 millimeters.
2.0 to 4.76 millimeters.
We'll say 2 to 4 millimeters. Medium sand?
Hold on.
Let me keep looking.
.425 to 2 millimeters.
No, I think let's call it 0.5 to 2. That's not quite. We're getting a little bit off. And then fine sand. The reason
0.075 to 2 millimeters.
0.1 to 0.5. The reason, and these are all estimates, as you heard her say, a little bit more technical numbers, and it's because I think these are originally given in inches, like they're still used in inches, they're just now been transferred to millimeters about, you know what I mean? Like the original definitions were a 64th of an inch to a 32nd of an inch or whatever, and then we've transferred those to millimeters. What's smaller than sand?
Grain.
Have you ever heard of silt? Do you remember these from 8th grade science at all? Am I barking up the wrong tree here?
Barking up the wrong
Okay, silt. What's the size of silt?
Am I supposed to know from 8th grade science?
No, we didn't do these sizes in 8th grade science. In fact, I've never done this before, but I'm happy that Kyler has her laptop here because we can do them.
0.002 to 0.05 millimeters.
And then smaller than that we call clay. So those are the grain sizes. And then the shapes are angular or rounded. Usually we do that for like medium coarse sand and pebbles. We don't really look at that for these bottom ones because it doesn't really. For one thing, clay and to some extent silt tend to be what we call platy, where they form flat little guys instead of rounded or angular ones. But angular or rounded. And this is determined by time in erosional media. So basically, the longer it has been in whatever environment is causing it to be eroded, the more rounded it gets. Why might that be? How come it goes from angular to rounder the longer it spends in its erosional medium, do you think? Well, he's not the only one there, right? If we have a whole bunch of what start out as roughly cubic, we'll say, crystals, which are angular, the more they move around together, the more they become round. Why might that be? They're doing what with each other? They're moving, they're bonking into each other, exactly right. So as all these cubes bonk into each other, the corners get knocked off, and then they're like dodecahedrons, and those corners get knocked off, and they get rounder and rounder and rounder the more bumping around they do. The rocks we call, maybe we should have like a table. Well, let's just do it this way. The rocks that form when these are lithified, if it's pebble-sized rocks are, and let me make sure you can see this, and they're angular, we call that arkose. Nope, I lied. Don't write that down. Don't write that down. Don't you dare write that down. It's called breccia. Breccia. And if it's pebble-sized but rounded, we call that conglomerate. Breccia is the Latin word for broken. I should have gotten an example of that. We should, you know what, we're kind of running out of time, and we should do this again on Monday. We continue this discussion Monday, I should bring out some examples. But we'll finish these first. Angular is breccia, B-R-E-C-C-I-A, and rounded is conglomerate. Conglomerate. Have you ever heard the word conglomerate before? You do conglomerate. Conglomerators do be conglomerating. Like when you guys all group together by the classroom door when it's almost lunchtime, that's a conglomeration. Conglomerate. And that's what this word means too. It's like these rounded pebbles that are... Sand? Can you guess what we call sand-sized particles that are lithified together? Sand.
Stone.
Stone. Good. Sandstone.
Oh, I know that.
Silt, we call siltstone, or sometimes we call it mudstone. And if it's clay, we call it shale. So these are the sedimentary rocks, depending on the grain size. Now, don't let me forget this because I am going to forget it. There are two whole other categories. This category of sedimentary rock is called clastic.
Clay is what?
Clastic shale. Clastic sedimentary rock. Clastic means broken. Basically, these are all things that are physically broken by the environment. But there are two whole other categories, which are evaporites and biosedimentary. And we'll get to that next time on Monday. But will you please, I'm gonna tell you right now, I'm gonna be very prone to just moving on entirely from sedimentary rocks, but we haven't talked about these at all. So someone remind me, we need to talk about these other two kinds of sedimentary rocks before we do metamorphic and igneous, okay?
Alright.
Who is it? Someone is not specific enough.
Sigh.
Sai, you remind me that we're gonna talk about evaporites instead of biosedimentary rocks before we move on to metamorphic and igneous. Yes? Okay, earth science time. We are talking today about, we're going to continue our discussion about rocks by talking about the other categories of sedimentary rocks that we missed or we ran out of time for on Friday. And we are going to then move on to metamorphic and igneous rocks, probably in that order. And remember that we relate these things by the rock cycle, which we explained. We explained cycles in general, and we explained the rock cycle in particular. And now, mostly today, we're talking about how do we categorize rocks, which is going to be really important for you because for the rest of this week, after this discussion, you're going to be categorizing rocks. Like, we're going to be in the lab. I have some examples here, but we're going to go in the lab, and there are more examples, and you're going to categorize them like you did for the minerals, but with rocks instead. Yes? Okay. So, we had talked already about, well, we started to talk about clastic sedimentary rocks. You remember that? Is that in everyone? Does anyone's notes? Does anyone in here not have the phrase clastic sedimentary rocks in their notes?
I wasn't
You
here on
don't.
Friday.
You
though.
did watch the video? Oh, I didn't post the video because this is going to be a two-parter. I think what I'll actually do is, my goal was to stitch them together and then post them as one. So
Yes, sir.
you'll have to watch the first part of that one. You can, Kyler will help you for now. So clastic sedimentary rocks are those rocks that are made of, you can label this rock again. The classic sedimentary rocks are those rocks that are made from bits of other rocks. Could they be other sedimentary rocks? Certainly. Could they be bits of igneous, what was igneous rock or metamorphic rock? Of course. Any kind of rock that is weathered, broken, and eroded, moved, forms of sedimentary rock. So we have weathering, which we said was the breaking of rock. Erosion, which is the movement of that broken material. BT-dub, what do we call that broken material? The stuff that has been weathered from whole rock. What do we call it? Sediment. Sediment. And then erosion, debris would maybe be an okay word, but sediment is what we usually use. Erosion is its movement. And then what do you think, we didn't say this word yet, but what do you think deposition is?
Putting it down.
Putting it down, yeah, it's done moving. Forever?
No.
Not usually, no. Usually there's some more than weathering and erosion. We could say that then it is then lithified through the processes of compaction and cementation. Remember that compaction is squishing the sediment together, making it compact, and cementation is when it is cemented together. And either or both of those can happen to make it into a rock.
Compaction and
What could cementation, like cement? What could cement some rocks together, some chunks of rocks together to make one sedimentary rock?
Cement. Pressure.
Okay, so you can't just say cement. Pressure provides the compaction. Mud, that's what I'm looking for. Usually some minerals in solution, which isn't necessarily mud, but also it could be, mud is minerals maybe in suspension, or it could be minerals in solution. If it was minerals in solution, then as the water dries, the minerals crystallize out and they hold the sediments together. That's one way it can happen. If it's mud, same thing, except instead of it coming out of solution, the water evaporates and the mud is just left. That's probably the more common. But this is how a rock is formed from another rock. So it starts out with some rock, or I should put that at the top, or I could have just done that. Some rock is weathered, broken down, that stuff moves, stops moving, and is then lithified to form a clastic sedimentary rock. So all of this forms a clastic sedimentary rock. Does it matter what the first rock was?
No.
Not for this process, right? It'll change the end result. For instance, I'm going to have two rocks here. I'm going to have at least two rocks here. I just want to be a little bit closer. Okay, I have two rocks here. Come here, camera. I have this rock, 30, and I have this rock, 33. Now, this one's 30 and this one's 33. What are some differences between these two rocks? I'm going to pass around in a second so you can tell me some more
One's
information on
old
it.
and one's ones.
Okay, so right from what you can see, this one's yellow and this one is gray. That probably had to do with what the rock was they started from. Because remember, these clastic sedimentary rocks are broken up pieces of other rocks. So when I say does it matter, I mean, well, the answer is no, in so much as the process doesn't change, depending on what this was, but the result does change. That's one of the ways that we can tell specific types. For instance, this is sandstone. This is shale. One of the ways that we can tell specific types of shale, that is shale from north of Hot Springs versus shale from New Mexico. One of the ways we tell them apart is by their color. Same thing with the sandstone. If you've been to Hot Springs, South Dakota, there are all those like orangish pink buildings are made of the sandstone that's local to the area. So different kinds of sandstone might have different colors, different textures, different chemical compositions would be the best way to tell about rocks. But as kind of a little side note, whereas color was a terrible way to tell what a mineral was, it's a pretty good way to tell different types of, not the different types of rock, but different locales of a specific rock, like this sandstone versus the pink sandstone in Hot Springs. Okay, so I'm going to pass these two around. Sandstone, what should we expect? What's the main difference as far as categorization between these two? They're what? Yeah, you're saying roughness, but grain size is what I'm looking for. So this one is going to feel rougher than this because it has a larger grain size. Why does it have a larger grain size? Probably less time spent in the erosional medium. That's what we had from Friday. Let me also find you in. So I'm going to pass these things around that we had already talked about, or a few of them around that we had already talked about, and then we'll move on to the other kinds of sedimentary rock. If I could just even find them, though, that would be really, really nice. If I could just even find something that I'm looking for, that would be really nice. This one will work. Some part of this video is going to be me rummaging through my box of rocks and saying, maybe I'll cut it. Probably not. Okay, well, I'm just going to go with these for now, and then maybe as I'm going around, I'll find some other ones. I would call this one breccia. So this has some angular chunks. And remember, breccia is angular pebble-sized sediment cemented together. I'm going to call this one conglomerate, which is rounded pebble-sized sediment cemented together. This one was sandstone, and this other one I have 33 is the shale. I'm going to pass those around. You can feel and see the differences, hopefully. Okay, there are other kinds of, so that was clastic sedimentary rocks. Those are the rocks that are made of broken bits, clasts, smooshed together. We also have chemical sedimentary rocks. So where clastic sedimentary rocks were made of broken up pieces of other pre-existing rock, these form from solution. Form from solution. What does that mean, Lily?
That they were in a solution and then
Yeah, they were dissolved in the water or whatever the solvent, almost certainly water. We sometimes call them evaporites. Chemical sedimentary rocks. We sometimes call evaporites. So here's an example. This is gypsum. Gypsum flowers. This is chert. Chert is sometimes called microcrystalline quartz. I could call, this one I might call flint or I might call chert. The difference between chert and flint is dark or light, but this is also microcrystalline quartz. Some of these you might have heard from Minecraft, if you're a Minecrafter. This one I probably would call flint. Let's see what else have we got in here. What would be a chemical sedimentary rock? Well, we'll start with these. So we have this gypsum, which is calcium sulfate. One of the reasons it's this shape is that these are the crystals of calcium sulfate that have grown. Are these minerals?
Sure.
Yeah, they're crystalline. They're made of an inorganic material. They're naturally occurring. They're a solid at room temperature. This is made of minerals, but it is also rock. This object is a rock. This is microcrystalline quartz. So So these again are crystals. They're microcrystalline, and so they're very, very, very smooth. And it's silicate minerals generally are not very easily dissolved, and so the chert usually has to form from pretty hot water. But these examples of these are like chert or flint, which are both microcrystalline
How do you spell that? Sure.
quartz. C-H-E-R-T. And these are silicates. Another example we had here is gypsum, which is calcium sulfate. The calcite, a mineral, when it forms in this way, is called limestone, and that's calcium carbonate. I believe I have some of that in here too.
Microcrystalline what? Quartz? Yeah.
Yep. This is a little chunk of limestone. So this is calcium carbonate. This is would be made of the mineral calcite. But as a rock, the limestone is very, very important. I would say probably the most discussed rock in this class would be limestone. One of the things that makes it so important is that it dissolves in even slightly acidic water. I'm trying to identify this. This might be rock salt. The mineral halite as a rock is called rock salt. I don't think the crystal is quite right. But either way, that's definitely a chemical sedimentary rock. So these crystallize out of solution. They appear as crystals. In things like the chert and the flint, they're microcrystalline because they form very fast, and we'll talk more about that when we talk about igneous rocks, because those form as crystals too. And then the other class of sedimentary rock is biochemical.
I wonder when these expire.
Biochemical sedimentary. What do you think these are? What would be the difference between chemical and biochemical sedimentary rocks? Biochemical,
life.
yeah, biochemicals formed by life. So this is a biochemical sedimentary rock. They would say this. You already know.
Obsidian.
No. Okay, you don't know what it is. Here's another example of it. You know what this is, I think.
Probably.
It's Christmas.
Coal.
This is it's coal. These are coal. No, so they're classified as sedimentary rocks, but they form because living things, in this case, what?
Trees.
Trees, yeah, plants from the Carboniferous, were compressed,
Coal is a non-renewable
squished, it's just
resource.
coal is a non-renewable resource that is no longer made.
Well.
Let's see what other biochemical sedimentary rocks we have in here.
Put your cheek.
So this isn't something you can use to burn.
You could burn it, yes.
It's the same thing.
Let me find my other example of biochemical sedimentary rock in here.
So nice.
I like this song. I think.
Oh, check this out. I love this one. This is one of my favorite samples of rock in this whole collection. So you can see on the top there, this has these snail shells right in it. So this is called fossiliferous limestone. So this whole thing, if you look even a little bit close at this, you'll see this whole thing is made of just like a crunch load of snail shells. It's called fossiliferous limestone, and it's just limestone that bears fossils. That's what fossiliferous means. It is a rock.
I thought it was.
this is-
Borrow this.
No, this is fossiliferous limestone. So we have examples here: coal, and fossiliferous limestone. Fossiliferous limestone. And then if the whole thing is entirely made of fossils, that one might be counted as, we call it coquina. C-O-Q-U-I-N-A, coquina.
Fossil what?
Fossiliferous limestone.
Yep.
This is another example of fossiliferous limestone. This one is red, just to show that it probably has some iron oxide impurities in it. Okay, so those are sedimentary rocks. They're generally formed from small pieces. Very small pieces in the case of chemical sedimentary, and small pieces of critters in biochemical sedimentary, but they're formed from pieces of something. That's what sedimentary means. It means that they are formed from sediment. Well, here's another example I have this one right here. This is probably calcite or gypsum too, but this is what we call a geode, but it's got crystals that form inside of this little nodule. Basically, I think this is pretty cool, but what it would have been is that this would have started out as like a bubble in some other rock, and since there was this bubble here full of gas, the crystals that are inside of it would have had longer to grow, and the longer a crystal has to grow, the bigger it gets. Just like the longer a kitten, if your kitten doesn't get hit by a train, the longer it has to grow, the bigger it gets. Same thing with a crystal. And so since these formed in a bubble, they had a lot longer to grow than the minerals around them, because the minerals around them would have been crunched together and they would have stopped growing. But since there was a bubble, so that's how a geode forms. Kind of a cool example of a biochemical sedimentary rock. Here's its other half. Okay, let's move on to metamorphic. Questions about chemical or biochemical sedimentary, or even classical. Questions about this at all? How do we grade these? How do we categorize these by their classic? By their
The green size.
grain size. These we kind of just tell the difference between them. Same with these. Okay, so write down metamorphic rocks. We're now on metamorphic rocks. What is metamorphosis? What does that word mean?
Change.
Change, yeah. Change in what? Meta means change. It really means across, but it means that something is changing.
Ooh.
From what? In its what? In metamorphosis.
One form to
Yeah. Metamorphic
I
means
don't like that.
change in form. I like that a lot, really. Form, shape. Morphos is the Greek word for shape. Form is the Latin form. Formus is the Latin word for shape. But it changes the way it is, basically. It changes its nature because of what? What is it exposed to that changes it?
Whoa.
Heat and pressure. Where does the heat and pressure come from? There are four, I think I'm going to say 4 different ways that we get this heat and pressure.
Magma.
One is, okay, let's say rock near magma. Why not the magma itself? I thought the magma was rock, we said. It is, but that rock is going to become what? Because it's magma.
Igneous.
It's going to become igneous. But the rock near the magma, we sometimes call this baked rock, becomes metamorphic. It's touching the magma, and so it changes because of the heat of the magma, but it itself doesn't melt. And so it stays solid, becomes baked rock, which we call, or which is a type of metamorphic rock, or a way that metamorphic rock can form. What else? What other way do you think metamorphic rocks can form? Not usually, but you have the right hand motion at least. What other large scale thing?
tectonic.
Yeah. We call this regional metamorphism due to plate tectonics. So they get really, really, really squished, much more than just the compaction in lithification of sedimentary rocks. They get really squished by plates.
How do they get in between the plates?
The plates are made of rock. And so the parts that are being smooshed together, right, regionally metamorphosed. It's called regional because it takes place over a large area. 3, what's another way? What else could they contact that would make them get really, really hot? Especially deep down in planet Earth.
The core.
Hot what? What other things can be hot about planet Earth? Yep, nice job, Peyton. Thanks for that.
Water.
Water, there you go. Hydrothermal. I'm really surprised you came up with that. I gave you a terrible clue, but great job. Hydrothermal metamorphism. And these are the ways that can happen, but they don't result in different kinds of metamorphic rock. The kind of metamorphic rock is how much metamorphism is one way we grade them, and what kind of stuff they were to begin with is the other way. Another way, kind of rare, in fact your new book that I use now doesn't even include this, but I really like it. I think it's the sexiest, and it's called Impact Metamorphism. Guess what it is?
Being 2 rocks hitting each other.
No. Yeah, not wrong. Where did the second of the 2 rocks come from?
Space.
Yeah, space rock. So when there's the reason that your second book or your new book doesn't even mention this because it's pretty rare. There are other clues besides the metamorphism that has occurred, but impact metamorphism is one of them. So the way we categorize them, these are how they happen, but they're not how we categorize them. We categorize them into either foliated
Well.
or non-foliated. What does anyone know what the word, the Latin word folius means? Like the foliage.
Leaf.
Leaf. It means leaf. Foliated are rocks where the minerals are kind of swooshing together like a little pile of leaves, where the flatnesses are all going together. In non-foliated, that doesn't happen. Foliated usually are, well, almost always, or maybe even to my knowledge always, are coming from a sedimentary rock like shale, where it's made of clay-sized, maybe not clay-sized, but platy minerals. Platy meaning flat minerals. And the more squished it gets, the more it changes. So let's say it starts out with shale. Remember, this is not metamorphic. What kind of rock is shale?
Sedimentary.
Sedimentary, and it's made of what grain size?
Little.
Yeah, the littlest. Clay. So this is a piece of shale. I'm going to send this back around to you. Shale, under some what we would call low-grade metamorphism, becomes slate.
Maybe that.
When I say low-grade metamorphism, that's like a low-grade fever. Not very much heat and not very much pressure, but enough to count as metamorphism. Mid-grade metamorphism would result in, hold on. Here's the examples. I have slate here. This has never worked in my class, but one of the ways I was taught that you can tell shale and slate apart is that shale will go clunk and slate goes clink. Okay, they both make the sound of a rock hitting paper. Let me do it on this table. Clunk, clink. You see a little bit of a higher pitch there. It's because this has a higher what compared to the shale. Do you think the slate has a higher what because it's been squished?
Surface.
Density, yeah, it's become more dense because it's been squished, and so it has a slightly higher pitch resonance. You can kind of tell. Shale, slate. If they undergo a little bit, more pressure, let me show you my example.
That one.
Where is my? I need my example. Okay, well I can't find the example, but we'll say, I'm just going to call it phyllite. Which is related to the Greek word for leaf, phylos. And then that will become schist under higher pressure, and then that will become gneiss under the highest. And other things can become gneiss too. In fact, a lot of times granite will become gneiss. This is a really, I think, very pretty example. Let me find the phyllite first. If there is any. We might have to skip the phyllite as far as the examples might have fallen out. But this is a really pretty, in my opinion, this is a very pretty piece of rock called garnet schist. So you can see it even has these little garnet, which is a semi-precious gemstone. Both of these schists have garnet in them. And basically the garnet has kind of come out while this was being squished, while the phyllite or the slate or whatever was being squished, the garnet crystallized out of it. And the garnet is so it has these little like beautiful nodules of these gemstones called garnet. It almost looks like a little really hard chocolate chip cookie. And then an example of gneiss. I really haven't had an example of gneiss. This is another piece of garnet schist. This one's a beautiful piece of garnet schist. So here we go. Here's an example of gneiss. So the characteristic pattern of gneiss is this kind of zebra pattern. It has these stripes of different, basically, the more heat and pressure are on these without them melting, the crystals, the different kinds of crystals separate out more. That's why we call it foliate. It looks like a little pile of leaves, like there were stripes on it. And they separate out more because they have different densities and solubilities and things like that. But they end up with this pattern, this repeating pattern of minerals, of types of minerals. On the other side, on the non-foliated side, and these are not leading one to another, but sandstone, the sedimentary rock sandstone, when it is squished, when it is metamorphosed, does not form a foliated one because those minerals are not platy. They're squares or circles or whatever, and that forms quartzite. Quartzite. If you have pink rock, in your driveway or in your road or whatever, it's probably this metamorphic rock, quartzite.
I have red rock.
Yeah, the red rock, that's what I'm talking about, is quartzite. It's crushed quartzite. So this is quartzite, it's metamorphosed sandstone.
What was this one green?
Um,
That looks like a driveway.
This is turquoise.
Nope, I said it's garnet. And another example of
Lily.
if we have limestone, a sedimentary rock, that becomes squished by metamorphosis, it forms marble. You know what marble is already, but this is an example of marble. It's metamorphosed limestone. This is marble.
No, it's not.
And I put 3 dots. I thought there was one more, but I might have to call back good. How in general do metamorphic rocks form?
Heat and pressure.
Heat and pressure. Without melting. Marble is metamorphosed limestone. Quartzite is metamorphosed sandstone. Of course, there are other kinds of both foliated and non-foliated metamorphic rocks. These are just the examples I have on here.
Where?
Okay. Let's talk now about questions about metamorphic rock before we move on. Sorry. We good on time? We're doing all right.
5 minutes, 6 minutes.
Okay. The next kind of rock, the next broad category of rock is igneous. What word do you think igneous is like unto? What do you think that's related to? Yeah, ignite, is that what you said? Yeah? And so both of those relate to fire. These are rocks that have been melted and cooled. Usually crystallized. Crystallized kind of like the biochemical sedimentary rocks form crystals, but instead of being formed from a solution at maybe roughly room temperature, these are formed from molten rock that has crystallized. We grade these by their color, which tells us about their composition, and their grain size, their crystal size, which tells us about their location. So we have color on one axis, which tells us about its composition. And this goes from, let's put felsic on this end to mafic on the other. Felsic stands for feldspar and silicates. Even though feldspar is a silicate. Mafic stands for manganese and iron. Why would F stand for iron?
Because it's F.
Generally, these are light and these are dark. They can have other like hues, but the shades are light to dark. On the other axis, we have
How do you spell that M word?
mafic, M-A-F-I-C.
No.
Manganese.
Manganese is on the periodic table, M-A-N-G-A-N-E-S-E. Not magnesium, don't get confused, manganese. On the other axis, we have crystal size. From, let me think of how I want to have this be. It doesn't really matter, let me think of how I want it. Let's put small up here to large down here. And small indicates that it cooled for a short time. Short time. And large crystals indicate that it cooled for a long time. By proxy, short time means that it probably cooled where?
Closer to the surface.
The surface. We call this extrusive and this intrusive, because the long time one's probably cooled where?
Deep down.
Deep down. So now we end up with this 2x3 table here, where we'll have felsic small, felsic large, intermediate small and large, and mafic small and large. I don't think I have examples of all these, but I think I do remember the names, hopefully. If we have light with small crystals, generally, if the crystals are too small to be seen with the naked eye, we say small crystals. And if they're big enough to be seen with the naked eye, like if you can individually see the crystals, we call that intrusive. We call this one rhyolite. We call this one granite. We call this one, this one's gabbro. And this one's basalt. Let me think about these two in the middle. One of them's diorite, and the other one's andesite. I can never remember which. I think this one, let me just tell you, let me just do it right. Sorry, make me feel like an idiot, but I'm gonna feel like even more of an idiot if I say it wrong. Andesite is the extrusive one. This is named after the Andes mountains. Oh, there's a diorite. Now, if they have no crystals at all, if they were cooled so fast that no crystals can form, we call that glassy, and we call that obsidian. And obsidian can be light or dark. It's usually black, but it comes in anywhere from like lightish pink or green to different hues of black. Glassy we call obsidian. Also, there are vesicular. Is anyone in med terms? What does vesicular mean? No one's in med terms.
Well, we took med
Oh,
terms last
what does vesicular mean? Yeah, referring to the what organ of the body? Do you know? Bladder. Vesicular means it has bubbles. It's like a hollow thing. Vesicular, we would call those either pumice. You've probably heard of pumice if it's light, or scoria if it's dark. And then there's also this other idea of porphyry, which is where it has large crystals in a small matrix. Kind of. Now remember that this schist is a metamorphic rock, but it would be kind of like this, where the matrix, where the main rock is small grain, but there are big old crystals. And I don't think I have any examples of that, but that's what it would be like, where there would be large crystals that grow in an otherwise small rock. So let's get some examples out here. Well, you know what? Let's get some examples out here. I would call this one's definitely large grain. You can see the individual crystals. Boop. Definitely large grain, and I would call this intermediate. So large grained, intrusive, intermediate, I would call this diorite. Never mind, we're not going to look at these examples. But hey, one last rock before you go. There's this one with the large hollow crystals, meaning the crystals have had time to grow as big as they can. Hollow meaning whole is called pegmatite. And I do have an example that I want you to look at of that, which is this pretty big boy here. Where's my pretty big boy? This one. This is what we saw a lot of that when we were climbing Hardy Peak. So there's these really huge crystals, like these big old books of mica in there. Like the crystals are bigger than my fingernail. They're very large crystals. We call it pegmatite. This happens when there has lots and lots and lots and lots of time to cool.